As mentioned already, a vector has a length and direction, but its starting point is always assumed to be the origin 0, 0, 0. We can think of the vectors being translated without changing its direction and length, but we cannot specify a vector as having the starting point somewhere else than 0, 0, 0. In some cases, in MaxScript, we want to create such a value that has both a direction and a unique user-defined starting point. In these cases, the array value can be used. Array value is constructed using the constructor array and has a position, for example 0, 0, 100, which is 100 units above the origin, and a direction, a vector, in this case pointing, for example, along the minus z-axis. Using this value, we can perform intersections with scene geometry. For example, if we would create a sphere close to the origin and then use the intersect ray function, we specify the geometry we want to intersect and the ray to use, and the result is a new ray with position at the point of intersection and direction, the normal vector of the surface that was intersected at the point of intersection. If the object was not hit, then the intersection is going to return undefined. This is why it's a good idea to always check if the intersection is not undefined. For example, let's create a point helper at the position of the hit. Let's move the sphere back close to the origin and perform the intersection with the sphere, and then create a point helper at the point of intersection. As you can see, now there is a point helper which is exactly on the way of the ray along the minus z-axis with coordinates 0, 0, 100 as the shooting point. If you would move the sphere a little bit and then perform another intersection and create a new point, the new point is at the new intersection exactly on the surface. The ray value is very similar to the way target objects like target cameras, target lights and tape helpers operate. And not surprisingly, we can convert any target object into an array. For example, we could create a target camera looking at the sphere and take this camera called camera 01 and convert to a ray value. Let's call this ray the ray 2 and try to create a point at position equal to the ray 2 position. As you would expect, this point was created exactly at the center of the camera. And if we would create a second point with position equal to the ray 2 position plus the ray 2 direction, multiplied by the camera 01 target distance, this point appears exactly at the target point. Now, we could try to perform a intersection between the camera and the sphere. For example, the second intersection, intersect ray sphere 01 and the camera 01 as ray. This intersection could be used to create, let's say, a dummy with position at the intersection 2's position. As you would expect, the dummy